Hello, ladies and gentlemen. I am Mohammed Hosseini and I am delighted to have the opportunity to present our research titled Enhancing Cloud Security, a study on the performance of Ensemble optimized DNNs for DDoS detection. This research work was conducted by myself along with my esteemed colleagues Karim Afdel, Mohammed Aqwar, Abdullah Barda, and Al-Hafid Aghrabi. Now, we begin with a brief introduction. Then we talk about the main problem. Next, we explain how to solve it. We share the test we did and what we found out. Lastly, we will wrap up by summarizing everything and discussing what comes next. Introduction. Cloud computing is the delivery of computing services, including servers, storage, databases, networking, software, analytics, and intelligence over the internet, as defined by Microsoft. From the data presented in the figure, there is a consistent increase in the global data centers network traffic each year from 2015 to 2020. The characteristic of cloud computing: on-demand self-service, broad network access, multi-tenancy and resource pooling, rapid elasticity and scalability, measured services, cloud computing architecture. This image presents a hierarchical diagram detailing various cloud service model, the resource managed at each layer, and some example platform associated with each model. From the top to bottom, the service model as software as a services, platform as a services, PaaS, infrastructures as a services, yes. Problematic. Therefore, cloud computing has many challenges. Security risks of cloud computing have become the top concern in 2018. DDoS attacks. Distributed denial of service attack is a type of attack that aims to make services or resources unavailable for indefinite amount of time by flooding it with useless traffic. In the figure, we see the process of DDoS attacks. The attacker operates a remote machine called a Bobmaster that control multiple machines to flood the target by useless traffic. This flood of traffic aims to overwhelm the target and distribute its normal functioning. The impact of DDoS attacks in the cloud environment: direct impact and indirect impact. The diagram represents the impact of DDoS attacks, breaking down the consequence into direct impacts and indirect impacts. For direct impacts, service downtime, economy losses due to downtime, businesses and revenue losses, disruptions to the depend services. For indirect impact, economic losses due to resources, energy consumption costs, attack mitigation costs, collateral damage to others. The proposed approach. Our proposed approach is develop an efficient detection system of DDoS attacks in the cloud. Our system is performed with 4 major steps: data collection and pre-processing, through models training, models validation, and ensemble model by voting. Data collection and pre-processing. Gather network traffic data from 2 datasets, CIDS 2018 and CIS DDoS 2019, reflecting real-world situations. Pre-process this data into phases, clean it by inconsistencies, errors, and filling in missing value. Normalizing it, adjusting variation in the future, and ensuring value ranging from 0 to 1 for consistent interpretation. Divide each dataset into subsets. 60% for training our model, 20% for validating during the training phase, 20% for testing and decision the model's final performance. Model training. At this stage, the training data is divided into 5 distinct subsets. Each subset is used as an input for training an individual deep neural network, DNN, and the ensemble. To optimize the performance of each network, we employ an optimization strategy that fine-tuning the hyperparameters using the Aquila optimizer. Model evaluation. To gauge the efficiency of the models in pointing DDoS attacks in the cloud, we utilize a suite of metrics: accuracy, precision, recall, F1 score, type error 1, type 2 error, ROC curve, and IUC score. Ensemble model by voting. We employ an ensemble model methods that capitalize on the collective strength of the 5 DNNs in our setup to effectively classify networks flow. This methodology enhances the decision-making capability of the system by leveraging the diversity and the independence of the individual DNN models. Now we show the experiments, results, and discussion. The experiments aim to show the effect of using optimized deep learning models for an efficient protection against DDoS attacks in the cloud. This table showcases the performance metrics for different DNN models in CIS DDoS 2019. The table shows high performance for 5 deep neural networks models, with the ensemble model excelling in all metrics, particularly in accuracy, F1 score, and lowest error rates. All models demonstrate high precision, recall, and specificity, indicating strong overall effectiveness. This is the radar chart for all models. This table highlights the performance metrics for different DNN models in CIS IDS 2018. The data show extremely high performance for all models, particularly notable in the ensemble model with near perfect scores in all metrics, including recall and the lowest error rates. All models display exceptional accuracy, precision, recall, F1 score, specificity, and IUC, indicating superior model performance with minimal errors rate. This is the radar chart for the models, all models. A conclusion: innovative ensemble DNN design introduce an ensemble optimized deep neural networks for efficient DDoS detection in the cloud system. Strength of collaborative models focus on combining prediction from multiple DNN models to enhance detection capabilities. Impact of hyperparameters optimization. Explore how tuning hyperparameters can significantly boost the ensemble optimizer performance. Benchmarking accuracy and efficiency. Highlight the superior performance of this approach over existing DDoS detection methods in the cloud environment. Validating true effective results. Present evaluation results demonstrating the approach's effectiveness in identifying DDoS attacks. Thank you for your attention. Don't hesitate to contact us if you have any questions.